Following explanation gives the basic science behind the world's first propellantless propulsion technology. EmDrive, the name given to the electromagnetic drive, is based on physics that has been known since Maxwell, Newton and Einstein. Radiation pressure within a guided structure was defined and demonstrated by Cullen 65 years ago, so there's no new physics required to explain EmDrive. From Maxwell's equations, we know that although electromagnetic waves have no mass, they carry energy and momentum when travelling in free space or inside a waveguide. If an electromagnetic wave is reflected by a fully conducting surface, the momentum is transferred to the surface and a force is produced, defined by the well-known radiation pressure equation F equals 2p over c, where F is the force in newtons, P is the power in watts, and C is the speed of light in meters per second. The image shows a model of a large communication satellite. Radiation pressure on the fixed flaps mounted off the solar arrays provides assistance to the roll and yaw control system and reduces propellant consumption over the satellite lifetime. EmDrive is essentially a microwave cavity where multiple reflections of a travelling electromagnetic wave occur at each end plate. These reflections cause forces at each end, and clearly the forces will increase with the number of reflections that take place. The electrical length of the cavity is an integer number of half wavelengths and is therefore a resonant system with a very large Q factor. Essentially, a very large number of reflections occur, which increase as the Q factor increases. An extreme example of this is the superconducting cavities in high-energy particle accelerators, where Q values can be in excess of 1 × 10 to the 9th. This causes large forces on the end plates, which stretch the niobium walls of the cavity and illustrate the potential for high thrusts in a superconducting EmDrive thruster. Einstein's theory of special relativity tells us that the speed of light c is constant. It follows that if an electromagnetic wave is travelling inside a cavity with velocity vg, no matter what the velocity of the cavity is, vc, an external observer will still measure the wave velocity as vg, not vg plus vc. vg is therefore independent of vc. Note also that any acceleration of the cavity is independent of an external reference. An observer inside the cavity could measure acceleration without seeing any external reference. The wave and cavity form an open system, and momentum can therefore be transferred between wave and cavity, enabling acceleration of the cavity. Vg is the group velocity of the energy, momentum and information in any guided wave structure. In a circular cavity, Vg varies with the diameter of the cavity and decreases with decreasing diameter until the velocity is zero. This is known as the cutoff point. The holes in the protective screen of a microwave oven door are a good example of this effect, as they are well below cutoff diameter for the operating frequency of the oven, but above that for visible light. Vg can also be reduced by inserting a dielectric element into the cavity. However, this does reduce thruster performance. In 1950, Cullen proved by experiment that the radiation pressure decreases as Vg decreases. Clearly, the end forces in a constant diameter cavity will cancel each other out. However, if the cavity is tapered, the force at the larger end, F1, will be greater than the force at the smaller end, F2. A net force on the cavity will therefore exist, which we call thrust, where thrust equals F1 minus F2. In a well-designed cavity, the group velocity at the large end, Vg1, approaches the speed of light, whilst that of the small end, Vg2, approaches 0. The thrust produced by any cavity design can be obtained from a simple thrust equation derived from the classic equations of Newton and Einstein. So in equation 1 we have F equals ma, where F is the force, m is the mass, and a the acceleration. In equation 2 we have E equals mc squared, where E is energy. Substituting equation 2 in equation 1 gives equation 3, F equals Ea over c squared. But E equals pt, where p is power and t is time, and A equals v over t, where v is velocity. So substituting these equations in equation 3 gives F equals pv over c squared. Now, for an electromagnetic wave reflected from the end plate of the cavity, the force is doubled because there is the force of the impacting wave plus the reaction force of the reflected wave. So we get F1 equals 2p Vg1 over c squared. Now this can be written as F1 equals 2p over c times Vg1 over c, which is the standard equation for radiation pressure times the ratio of Vg1 to c. For the total thrust on the tapered cavity, T equals 2pq over c times Vg1 minus Vg2 over c. Remember, we've already defined T as F1 minus F2 and Q as a measure of the number of reflections that take place within the resonant cavity. Now this equation can be conveniently written as T equals 2pq over c times df, where df is the design factor which is dependent on the diameter of the two end plates. A question that is always raised is that surely the difference in end plate forces is balanced out by the force on the sidewall of the cavity. Now it's important to understand that the field structure within the cavity is the superposition of a standing wave varying with time and multiple travelling waves varying with both time and position. For the standing wave, which is itself a result of the travelling waves varying in phase, the sidewall force does indeed cancel out the end plate forces. However, for a travelling wave, the maximum force is achieved when the wavefront is reflected at right angles to the end plate. In a well-designed cavity, the travelling waves are moving parallel to the cavity wall at the wall surface, and the force is therefore zero. So the thrust is due only to the end plate forces. To separate EmDrive operation from magic, it must obey the law of conservation of momentum. Although inside the cavity Einstein rules because the electromagnetic waves are travelling at relativistic velocities, to the outside world it is simply another Newtonian machine. Thus the thrust caused by the internal force imbalance against the large end plate is seen as a force pushing against the outside world. The end plate, remember, is a non-elastic material. For an unconstrained cavity, Newton's third law says that this force must be balanced by an acceleration in the opposite direction. Now, this effect has been consistently measured in experiments. Thus, the momentum gained by an accelerating cavity in one direction is balanced by the momentum lost by the electromagnetic wave in the other direction. Note that if the thruster is constrained, for instance by a force measurement system, acceleration is replaced by a reaction force. This reaction force balances the thrust, and so no net force is measured. So clearly, measurement of either thrust or reaction force requires a carefully designed force balance, which allows some acceleration of the cavity to take place. Similarly, to be a viable theory, EmDrive must obey the law of conservation of energy. The energy balance is illustrated in the diagram, which shows the input microwave energy is temporarily stored as in any resonant system. It is then released as a kinetic energy and thermal energy over the time constant of the cavity. Remember, the stored energy is defined as Q times the energy lost per cycle. So if the stored energy decreases, for instance as some of it is converted into kinetic energy, the Q of the system will decrease and therefore the thrust will decrease. Continuous energy input results in a continuous balance with kinetic energy and thermal energy output balancing the input microwave energy. Now, for a restrained cavity, the output is purely thermal energy. The acid test for any scientific theory is, does it make predictions which are demonstrated by experiment? Experimental data has been published for 7 different EmDrive thrusters from 5 organizations worldwide. The chart shows specific thrust, that is thrust in millinewtons per kilowatt of input power, plotted against the measured Q of the cavity. The data points can be compared with a predicted specific thrust characteristic shown in blue, which is based on the simple static thrust equation we have derived and assumes a design factor of 0.6. As can be seen, 5 of the thrusters sit very closely on the predicted line, whereas the 2 outliers are thrusters that rely on a dielectric element inside the cavity. Now, where thrusters have been allowed to accelerate, Newton's laws applied to EmDrive are seen to prevail. In other words, the thruster moves in the correct direction. Also, by calculating the thrust from the known mass and measured acceleration, the dynamic thrust for large mass to thrust ratios is seen to agree with measured static thrust. In summary, EmDrive is based on standard physics and has been proved by experiment. It is now up to the space and defence world to demonstrate the many